Let x and y be two-digit integers such that y is obtained by reversing the digits of x. The integers x and y satisfy x squared minus y squared equals m squared for some positive integer m. What is x plus y plus m? This implies that by the difference of squares, x plus y times x minus y is equal to m squared. And from this, it's clear that then x is greater than y here. So you can test this out. 21 minus 12, that's equal to 9. 31 minus 13, that's equal to 18, and so forth. You'll find that anytime you reverse the digits of x and subtract that from x, the result will always be a multiple of 9. And when we're looking at, so this is looking at x minus y. I want to look at these two things. X minus y, result will always be a multiple of 9. X plus y, do the same thing. 21 plus 12 is 33. 31 plus 13 is 44. Similarly, anytime you reverse the digits and sum them, this will always be a multiple of 11. And so it's then going to be true that 9 and 11 will always be factors of x plus y times x minus y. And so one important point here is, since 11 will always be a factor of x plus y times x minus y, we need 11 squared to be a factor of x plus y times x minus y. And I'll show you why in a sec. The reason why we need 11 squared to be a factor is because the largest number we can achieve here is going to be, we can achieve 72 in multiple ways, but it's going to be 72. So it's going to be true that 11 is never going to be a multiple of, or rather, yeah, 11 is never going to be a factor of x minus y. And so we need 11 squared to be a factor of x plus y. And similarly, here we need, if we're going to achieve m squared, we need to think of numbers squared. So if 11 squared, we know that's going to be a factor of x plus y. Looking at x minus y, we need 3 squared to be a factor. That if 11 squared is going to be a factor, it's going to be true that we want x plus y to equal 121 or 11 squared. Thinking about, what other number squared? It's not going to be 9 squared, because 9 won't be a factor of 121, which we'll have here, and we're never going to get to 81 here, because 72 is the largest value we can get for x minus y. So we need 3 squared to be a factor. And if 3 squared is a factor and 11 squared is a factor of that, then we can combine them, and that can equal some number squared. So first we need to show that this is possible. So I'm going to look at all scenarios where we can achieve x plus y is essentially 11 squared. So one situation is where 92 plus 29, reverse the digits, that's 121, which is 11 squared. The only thing is x minus y is 63, which is not a number squared. It's not 3 squared, so that won't work. Let's try 83 plus 38. It's also equal to 121, but again, that's 45. And we can keep going until eventually we run into the situation we want. And so here, 65 minus 56 is 9. So here's the situation. That's equal to 3 squared. That's equal to 11 squared. And I'll show how this works. So we found that 3 squared is equal to x minus y. So going back to that equation we were looking at above, and so from here, this is just the same thing as this. So m is equal to 33. And we found that here, so x is equal to 65, and y is equal to 56 in this case. And this is the situation we were looking for. And the problem was just asking us, what is x plus y plus m? Well, we have all these values. It's just summing them up. And that sum is 154, which is our answer. So the answer is choice E.